Hey everybody, welcome to Geometry, Section 7.4, Similarity in Right Triangles. By the end of this lesson, you should be able to use similarity in a right triangle to solve for missing lengths. You should also be able to find the geometric mean. So let's talk about similarity in a right triangle. So let's take a typical right triangle. We've got our little right angle symbol here. We've got two different angles. We've got a red angle and a blue angle. Now what I'm going to do is I'm going to go ahead and draw an altitude, which if you remember, an altitude goes from a vertex and then goes perpendicular to the opposite side. So I'm going to draw an altitude there. And now, how many triangles do I have? Well, some people would say, well, I've got this little triangle over here and I got this other triangle with the blue angle in it, so 2. But don't forget about the original triangle, the big triangle. Now, I used to call this the baby triangle, the mama triangle, and then the big daddy triangle. But some students expressed some discomfort in calling something the big daddy in geometry class. So what I'm going to do is I'm going to change it to the baby Yoda triangle, the Gamora triangle, and then the Hulk triangle. Okay? Illustrating tiny, medium, and large. So if we have this these 3 triangles, I want to point out real quick that this red angle right here is going to be the same as this red angle up here. And this blue angle is going to be the same as this blue angle. So what we have here is, since this baby Yoda triangle has a red angle and a blue angle, and this Gamora triangle has a red angle and a blue angle, you could say that by angle, those 2 triangles are similar. You could also say, since the Hulk triangle has this red angle and this blue angle, that it's also similar to the other 2. So all 3 of these triangles are the exact same shape of a triangle, just different sizes. So let me go ahead and put some letters on this, and I want to show you that if I start with triangle ABC, which is this baby Yoda triangle, I start at the blue angle, then go to the red, and then go to the right. Okay, I can make that similar to the Gamora triangle. So I start with the blue angle, then go to the red, then go to the right, so D, A, C. And lastly, the Hulk triangle, start at the red, go to the blue, and then into the right angle. So that would be, start with the blue, and then the red, and then the right, so D, B, A. So if you're wondering what a similarity statement would look like between those 3, because I'm sure you were wondering that exact same thing, that's what it would look like. So within any right triangle, there's always going to be a hypotenuse. You can always spot the hypotenuse because the right angle always points right at it. And then the other 2 sides are called legs. And typically with what we're doing in here, you'll have a short leg and a long leg. So the reason I want to do that is because I'm going to be talking about these sides, and I want you to know which sides I'm talking about. So I'll call them the hypotenuse, the short leg, and the long leg. So something I want you to know, there are 3 pieces in this picture here that are in 2 different triangles. So this side AB, it's the hypotenuse for the baby Yoda triangle. It's also the short leg for the Hulk triangle. Okay, side AD is the hypotenuse for the Gamora triangle, and it's also the long leg of the Hulk triangle. And finally, side AC, that's the short leg for the Gamora triangle. It's also the long leg for the baby Yoda triangle. Okay, so that's going to help us visualize things as we go to find missing lengths. So here's an example where I give you some lengths, and I want you to find how long segment CD is. So what I would do is I'd find one of those 3 segments that I just talked about that's in 2 different triangles. In this case, side AC. So side AC is in both the baby Yoda triangle and the Gamora triangle. So I'm going to focus on just the baby Yoda triangle right now. I'm going to set up a little chart, and this little chart will help me set up a proportion to solve for x. So this 5 is the short leg in the baby Yoda triangle, and this 15 is the long leg. So then if I go to the Gamora triangle, the 15 is the short leg, and the x is the long leg. Now the benefit of setting up this chart is you can just take it directly and turn it into a proportion. And that's going to be easy enough to solve. So cross multiply 15 times 15, 5 times x. So 15 times 15 is 225. So 5x equals 225 divided by 5. Boom, you get x equals 45. Okay? So let's go ahead and look at a few more examples to kind of solidify this concept. All right, so if we take a look at this first example here, x is in both this baby Yoda triangle. It's also in the Hulk triangle. So I'm going to go ahead and set up my chart. So x is the hypotenuse in the Yoda triangle. And it is also the short leg in the Hulk triangle. All right, this 9 is the short leg in the Yoda triangle. And the 25 is the hypotenuse in the Hulk triangle. So then I'm going to take this little chart, I'm going to turn it directly into a proportion. So x over 25 equals 9 over x. Cross multiply, I get x squared equals, what is that, 225. Take the square root of both sides. I get x equals 15. Okay? So let's go ahead and take a look at another example. Okay, same numbers, they're just asking us to solve for something different. All right, so let's see here. We've got x. Okay, that's one of those segments that's in two different triangles. X is in the Baby Yoda triangle and the Gamora triangle. So in the Yoda triangle, X is the long leg. And 9 is the short leg. It doesn't matter what order you fill out this chart. In the Gamora, the X is the short leg. And the 25, well, hang on a second. 25 is the hypotenuse of the Hulk triangle. I'm not dealing with the Hulk triangle, but something that I can do, if I know that that entire hypotenuse is 25 and just part of it is 9, I can do some simple subtraction and say that this part here is 16. So I know that that 16 is the long leg in the Gamora. So now take that chart, translate it directly into a proportion. Cross multiply, I get x squared equals 144. Square root both sides, you get x equals 12. Okay, let's do another one. All right, so this x is in both the little baby triangle and the Gamora triangle. Okay, so over in this baby triangle, 7 is the short leg, and in this one, it's kind of tough to see which one's the short one, which one's the long one. All right, so in the baby triangle, what's along the big hypotenuse is going to be the short leg, so 7 is the short leg. And x is the long leg. Now, I'll give you a heads up. That x is not going to be the long leg in both triangles. That x is going to be the short leg in the Gomorrah triangle. And then the 9 is going to be the long leg. So now we'll go ahead and set up our proportion. 7 over x equals x over 9. And just a heads up, if you have x over x in your proportion, you've done it wrong. Okay? If you have both x's on top, you've done it wrong. If you have both x's on bottom, you've done it wrong. Okay? If you have x two different places, they should be diagonal in problems like this. So cross multiply, I get x squared. 7 times 9 is 63. Square root both sides. And in future lessons, we're going to figure out how to simplify the square root of 63. For right now, let's just go ahead and use our calculator and get a decimal approximation. So let's do the square root of 63. We're looking at 7.9. So there's other ways to do these types of problems, and we'll talk about it in just a little bit, but this is the main way I want you to focus on how to find the missing links. Set up a chart, fill it in, and then use that chart to make a proportion. Okay, the second thing I wanted to talk to you about was geometric mean. Now, you may say, okay, wait a second, mean. I've heard that before, like mean, median, and mode. Kinda. So if I ask you to find the mean between 2 and 18, you think, okay, so mean is the average. So I'm going to go ahead and add up those two numbers and then divide by 2. So that makes 20. 20 divided by 2 is 10. Okay, so that's what we're used to finding when we talk about the mean, the average. Just to add up all the numbers and divide by how many numbers that are there. Okay, another way to think of it is if I were to spread these three numbers apart, okay, how do I go from 2 to 10? Well, by adding 8. And then to go from 10 to 18, I add 8 again. So that's another way to think of the mean, is to get from the one number to the middle number, you're adding by something. And then to get to the next number, you're adding by the exact same thing. So these are two different ways to envision the exact same concept. Now, just a heads up, this is what's known as the arithmetic mean. Arithmetic is where we get our word arithmetic, okay? But that's what we're used to seeing. We're talking about the geometric mean, which is slightly different. So if I said find the geometric mean between 2 and 18, what I'm asking you to find is, okay, if I've got 2 and 18, what number in the middle could I find where I multiply by something to get x, and then multiply by the exact same thing to get 18? So instead of adding to get to the middle and then adding to get to the end, I'm multiplying to get to the middle and multiplying to get to the end. So the idea to focus on is the ratio between 2 to x is going to be the exact same thing as the ratio of 18 or of x to 18. Okay? So here we have a proportion, and we can now solve that. So cross multiply, and I get x squared equals 36. Take the square root of both sides, and I get x equals 6. So if you want to look at it by the multiplied by something idea, so to go from 2 to 6, I have to multiply by 3. And then to go from 6 to 18, I again multiply by 3. So that's the idea of geometric mean, is we're multiplying to get to these numbers, not adding to get to the numbers. So an easier way of doing this, rather than set up that big proportion the whole time, is very quick formula. If I have two numbers, a and b, to find the geometric mean, I just multiply them together and then take the square root. So rather than set up that whole proportion, I could just say 2 times 18, take the square root of it. 2 times 18 is 36. Square root of that is 6. So anytime it says find the geometric mean between two numbers, that's what I would do, is multiply them together and take the square root. Now, some other formulas that you can use that same proportion formula that we just discovered. Or here's another one, x squared equals ab. It's basically the same thing, except they haven't taken the square root yet, all right? So anytime it says use or find the geometric mean, you can use any of these formulas. But I would highly recommend using x equals the square root of ab, where x represents your geometric mean, and the a and the b represent the two numbers that are given to you. So let's take a look at a few examples to kind of go through this. So here we have a few problems, 2 and 8. So to find the geometric mean between 2 and 8, I'm going to use that formula. So x equals the square root of 2 times 8. X equals the square root of 16. So x equals 4. Pretty easy. 9 and 16. So the square root of 9 times 16. 9 times 16 is 144. So x would equal 12. Okay, number 8. So x equals the square root of 4 times 5. 4 times 5 is 20. Now, like I said, in a future lesson, we're going to learn how to simplify the square root of 20. For right now, I'd be fine if you left it as square root of 20, or if you found the decimal approximation. So 4.5, roughly. Okay, in the future, I'm going to look for something like this. And I don't expect you to know how to do this now, but we'll get there. Okay? Let's take a look at this last problem. It says 15 is the geometric mean of 25 and what other number? So instead of giving you the two numbers and expecting you to find the geometric mean, it's saying here's one of the numbers, here's the geometric mean, what's the other number? Now remember in the slideshow I gave you 3 different formulas. Obviously there's the x equals the square root of AB one, which is great most of the time. And then closely related to that is x squared equals AB. This is about the only time I would use that x squared equals AB is if they give you the geometric mean and ask for one of the other numbers. So in this case, it says 15 is the geometric mean, so I'll plug that in for x. And then 25 is one of the numbers, and we don't know what the other number is. So now we can work this out. 15 squared is 225. Divide both sides by 25 and you get 9. So you may ask yourself, how does geometric mean relate to what we were talking about with similarity and right triangles? There is a connection, but since we're on a fully virtual schedule, I'm going to briefly touch on this, but I really want you to focus on the setting up the proportions to solve the missing links, because typically students who try to apply geometric mean to those triangles don't do so hot. So we're not going to hit it hard. I just want to show you that there is a connection. I also wanted to show you the geometric mean just in case you're taking a standardized test and they ask you about it, you're informed. Okay? So let's go ahead and get back to the slideshow and let me show you how geometric mean connects to those similar right triangles. So here we have that diagram that we had before. And what I want to show you here is that if I have this altitude, and that's my x, that is the geometric mean between this A and this B. So side BC and side CD. So x is the geometric mean between A and B. Another way we can use this is that the small side, or the short leg of the Hulk triangle, that is the geometric mean between side BC and then the entire Hulk hypotenuse. And likewise on the other side of the triangle, the long leg of the Hulk triangle is the geometric mean between the long leg of the Gamora triangle and the entire Hulk hypotenuse. So again, if what I just said made no sense, that's okay. I just want to show you that there is a connection. But again, go back to the proportions to find those missing links. So if you guys have any questions, please feel free to ask me. Again, if the geometric mean in relation to the triangles doesn't make sense, that's okay. But feel free to ask questions. Feel free to email me, and hopefully you can understand how to find x and also how to find the geometric mean. You guys have a good one, and I'll see you real soon.